Imagine the Earth is a machine, a system of cogs and motors, powered by the sun. But our world didn't come with an owner's manual. How does it operate? What are the inner workings of this grand and elaborate system known as planet Earth? And why is it so conducive to life? Scientists have launched an armada of satellites to help us understand what makes our world tick. They are discovering the answers strewn across its atmosphere, on every ocean and continent, in the far reaches of the solar system and beyond. Like any machine, the Earth is the sum of its parts. They were forged in distant furnaces of our galaxy. Supernova explosions. When ancient stars erupted, they showered the Milky Way with heavy elements: iron, calcium, potassium, the very stuff our bodies are made of. But supernovae are also thought to bombard the galaxy with lethal, high-energy particles. What safeguards our solar system is our star. The sun provides a shield, stretching beyond the last planet in its orbit, a force field that deflects these cosmic rays. But these solar winds can be dangerous too, especially during outbursts called coronal mass ejections. Want a vision of Earth gone wrong? Just look at what solar storms do to our sister planet, Venus. They strip away lighter elements in its upper atmosphere: hydrogen, oxygen, and the molecule they form, water. What's left is a witch's brew of noxious chemicals, including thick sulfurous clouds. Down at the surface, Venus's atmosphere is choked with high concentrations of carbon dioxide. CO2 is a potent greenhouse gas that traps the sun's heat. It has turned Venus into a cauldron. With surface temperatures at almost 500 degrees Celsius, this is the hottest planet in the solar system. How has Earth avoided the grim fate of Venus? We can see the answer as the solar storm approaches Earth. Our planet has a protective shield all its own, a powerful magnetic field generated deep within its core. In fact, that's just our first line of defense. Much of the solar energy that gets through is reflected back to space by clouds ice, and snow. The energy that Earth absorbs is just enough to power a remarkable planetary engine, the climate. It's set in motion by the unevenness of solar heating, due in part to the cycles of day and night and the seasons, that causes warm tropical winds to blow toward the poles and cold polar air toward the equator. Wind currents drive surface ocean currents. This computer simulation shows the Gulf Stream winding its way along the coast of North America. This great ocean river carries enough heat energy to power the industrial world 100 times over. It breaks down in massive whirlpools that spread warm tropical waters over northern seas. Below the surface, they mix with cold, deep currents that swirl around undersea ledges and mountains. Earth's climate engine has countless moving parts, tides and terrain, crosswinds and currents, all working to equalize temperatures around the globe. But when tropical heat builds to extremes, it can be released in a fury. In August 2005, within a huge looping section of the Gulf Stream, the ocean unleashed a monster. Hurricane Katrina. This is a supercomputer model of Katrina, a tool for scientists to better understand the dynamics of the hurricane system. To visualize the flow of air into the storm, they release a series of virtual streamers. Those with lighter colors are warmer winds. As they rise, they collide with the cooler air above and produce clouds. The winds increase the evaporation of warm seawater, which draws more and more heat from the ocean and causes the winds to accelerate. Moving around the eye of the storm, winds can reach speeds of up to 250 kilometers per hour. A powerful hurricane like Katrina can release as much heat energy every 20 minutes as a 10-megaton nuclear bomb. While storms release heat stored in the ocean, the moisture they stir into the atmosphere helps keep the rest of the planet warm. Water vapor traps solar energy, along with carbon dioxide, the same greenhouse gas that ruined Venus. The difference is that Earth has found a way to keep CO2 in check. We can see it for ourselves by flying down to the ocean. The special ingredient that sets Earth apart is called life. The oceans are chock full of it. Too small for our eyes to see, phytoplankton may be the most important living things on the planet. They take in CO2